Let's do a little review of perimeter and area. Previously, you've investigated, is there a relationship between area and perimeter? In other words, if we increase the area, do we automatically increase the perimeter? And vice versa. Hopefully you have a good idea of that. If you don't, please go back and redo the investigation between area and perimeter. So on these shapes are on centimeter grid paper. So find the area and perimeter of these shapes and label the appropriate units. Pause the video here, and then when you're ready and you have your answers, look at the next part of the video. So the shape on your left, if we're doing the perimeter, we're going the distance around the outside, and that's one-dimensional, so it's linear. So we can just count if we're going up the left. We can say, okay, that's 3 centimeters, then across the top 2 centimeters, then down 1 centimeter, across 2 centimeters, up 1 centimeter, across 1 centimeter, down 3 centimeters, and then all the way across 5 centimeters. So if we add 3 plus 2 plus 1 plus 2 plus 1 plus 1 plus 3 plus 5, we should get 18 centimeters. Notice that our units are just in centimeters. They're not square centimeters or cubic centimeters. It is a one-dimensional measurement. Then to find the area, in this case, I use just the counting squares method. So I just counted up here. We have 3, 6, 7, 8, 9, 10, 11, 12, 13. So there's 13 square centimeters of area in figure 1. Now, I could have used a different strategy. I could have used base times height or length times width, which would be 1, 2, 3, 4, 5 times 3, 15, and then subtracted off these 2 squares that aren't part of that larger rectangle that I drew. Either way, I'm going to get 13 square centimeters. On number 2, you use a similar strategy. So if we go up the left, that's 3 centimeters, then 2 centimeters, 1 centimeter, 1 centimeter, 1 centimeter, 1 centimeter, down 1 centimeter, and over 2 centimeters. So if we add those, 3 plus 2 plus 1 plus 1 plus 1 plus 1 plus 1 plus 2, we should get 12 centimeters. And again, that's a linear measurement, so it's just centimeters. Again, we could use the counting squares technique to find the area. We would get 7 square centimeters. Or we could use the larger rectangle and subtract, or we could split this into 2 shapes and then add those 2 together. Whatever strategy, as long as you get 7 square centimeters. Let's try another shape. Find the area of these 2. Make sure you label your formula and you show all your work throughout. You should always show your units throughout the problem so then students understand where the units are coming from. So try these 2, and when you're ready, move on to the next slide. All right, so the first shape was a triangle, and the formula for a triangle is 1/2 base times height. Some of you might think of it as base times height divided by 2. So if we do 1/2, the base of our triangle is 15, the height of our triangle is 4. So if we do 1/2 of 15 times 4, we would get 30 square inches. Notice now, since we're finding area, our units are in square inches. It's important that you're able to identify the polygon, the formula, show all your units throughout, and have your answer labeled clearly. On number 2, that is a trapezoid. So our formula for a trapezoid is 1/2 B1 plus B2 times H. Some of you might write that formula a little bit differently. So we take 1/2 of 8 centimeters plus 5 centimeters times 5 centimeters. For an answer, we would get 32.5 square centimeters. Notice that I have my units throughout my work. All right, I hope that was a great review of area and perimeter. Thanks for watching.